Welcome to the Day 21 video, which is our last video of Chapter 5. Today we are going to continue with completing the square. Yesterday we completed the square so that we were able to solve quadratic equations using the square root method. Today we are going to convert quadratic equations from standard form to vertex form. So today relates to graphing. Again, today's video is no calculator. It's going to be very similar to what we did yesterday, but a little bit of a difference. I thought we would just start by jumping right into example 1. It says write in vertex form and then graph. So we have this equation in standard form. It says y equals x squared plus 6x plus 5. We could find the vertex by negative b over 2a and make ourselves a table, but instead we're going to write it in vertex form. The difference from yesterday is that instead of being set equal to a number, our equation is set equal to y. So yesterday we added some number to the left side and to the right side in order to complete the square. Today we're only adding to the right side. We're not going to change that y at all. So as with yesterday, this last number has to be b divided by 2 squared. Our b in this case is 6 divided by 2 squared. 6 divided by 2 is 3, 3 squared is 9. That should be a 9, but it's not as of right now. So I'm going to need to add a 9. So we have y equals x squared, add 6x, and I'm going to put some space between the 6x and the 5. In order to have a perfect square trinomial, I need to have a 9. Okay, but I can't just add 9 just because I feel like it. If I add 9, I also have to subtract 9 to make up for it. Because adding 9 and subtracting 9 undo each other, and we're left with what we had. Now, this should be a perfect square trinomial. Two numbers that multiply to 9 and add to be 6, well, that's 3 and 3, which is good. It should be the same number twice. So this is going to be x add 3 squared, and then I just need to simplify. 5 subtract 9 is negative 4. And so now my equation was converted from standard form to vertex form. In this case, my vertex is negative 3 comma negative 4. And this would be the same if I found the vertex using negative b over 2a. So let's try that. Going back to our original equation, the vertex is negative b over 2a, which is what we've done before. We did that in the past. So that's negative 6 divided by 2 times 1, which is negative 3. If you substitute in negative 3, you also get negative 4. Just trust me on that one. Okay, so again, this is our final equation, which we just verified gave us the correct vertex both ways. Last thing when I graph is I'm going to need to make myself a table. So my vertex is negative 3, negative 4. I'm going to go down, negative 4, negative 5, and up, negative 2, negative 1. If I substitute in negative 4 into my new equation, I get negative 4, add 3, which is negative 1. Squared is 1. 1 subtract 4 is negative 3. So these should both be negative 3. If I substitute in negative 1, I get negative 1, add 3, which is 2. 2 squared is 4. 4 subtract 4 is 0. And then let's graph. Our vertex is negative 3, negative 4, which is about here. Then we have negative 2, negative 3, and negative 4, negative 3. Sorry, I know mine is not super accurate. And then negative 1, 0, and negative 5, 0. And there we go. We converted from standard form to vertex form and we graphed it. Our parabola is opening up, which makes sense. In the original equation, we have positive 1x squared. And then in our vertex form, we have a positive 1 in front of the x plus 3 squared. Okay, so that was example number 1. We are going to do a few more examples. Example 2. This one you're going to notice is a little different. We still have to write in vertex form and graph, but in this example, we have a negative 2x squared. Yesterday, when we had a coefficient in front of the x squared, we just divided our entire equation by that. We can't do that this time because we have this y here. So I can't divide everything by negative 2 because that would divide y by negative 2. So I'm going to rewrite this. It's negative 2x squared, add 8x. I'm going to add some number, and then I have my minus 1. So this right here is going to be my perfect square trinomial. What I'm going to do is I'm going to factor out the negative 2. So this becomes x squared. 8 divided by negative 2 is negative 4x, and then I still have to add something on. But I'm not dividing the negative 1 by negative 2. That I'm just leaving alone. Okay, now here is going to be our b over 2 squared, which in this case is negative 4 over 2 squared. So negative 4 divided by 2 is negative 2. Negative 2 squared is 4. So here I need to add a 4. Okay, but remember that if I add something, I need to undo that. Remember that I factored out a negative 2. So negative 2 multiplied by 4 is negative 8. So really I subtracted 8. To counteract that, I need to add 8. Okay, so again, I added a 4, but when I multiply that by negative 2, that's really like subtracting 8. The inverse of subtracting 8 is going to be to add 8. And now I should be ready to factor. My negative 2 stays the way that it is. Looking for two numbers that multiply to 4 and add to be negative 4. Well, that's negative 2 and negative 2, which is good. I have x subtract 2 squared. And then my negative 1 add 8 is going to be positive 7. And this is my final answer. In this case, my vertex is going to be 2, 7. Let's just verify that. If I use the standard form and I have negative b over 2a, that's negative 8 divided by 2 times negative 2. Negative 8 divided by negative 4 is positive 2. And if I substituted it in positive 2, I would get positive 7. Okay, so it's written in vertex form, and now we have to graph still. So 2, 7 is my vertex. Going down, I have 1, 0, and up is 3, 4. If I substitute in 3, 3 subtract 2 is 1. 1 squared is still 1. Multiplied by negative 2 is negative 2. Add 7 is 5. If I substitute in 4, 4 minus 2 is 2. 2 squared is 4. 4 multiplied by negative 2 is negative 8. Add 7 is negative 1. Now my vertex is 2, 7. And then I have 1, 5. And 3, 5. And then I have 0, negative 1. And 4, negative 1. Okay, and it's good that this is opening down. We have a negative 2x squared. So that's a good way to check our answer. So I know right now we're probably confused, which is okay. We're going to do another example together just to solidify what we have done. So, moving on to the next page. It says write in vertex form, and then graph. Okay, so I can only manipulate the right side of the equation. I can't manipulate that y at all. This number should be b divided by 2, so 4 divided by 2 squared. 4 divided by 2 is 2, 2 squared is 4. So I need a 4, but it's actually a negative 7. So I'm going to rewrite, so I have x squared, add 4x, and I'm going to leave that space. I need a 4 in order to complete the square. So I'm going to add a 4 here. Because I added a 4, I need to counteract that by subtracting a 4. Now, this should factor into a perfect square trinomial. Two numbers that multiply to 4 and add to be 4, well, that's 2 and 2. So this is really x add 2 squared. And then I have negative 7 and subtract 4, which is negative 11. So this is my equation in vertex form. Now if I make a table, I have negative 2, negative 11. So going down is negative 3, negative 4. Going up is negative 1, 0. If I substitute in negative 1, I have negative 1, add 2, which is 1. 1 squared is 1. 1 subtract 11 is negative 10. If you need to write this down because you can't do it in your head, that's fine. If I substitute in 0, I have 0 add 2 squared subtract 11. 0 add 2 is 2. 2 squared is 4. So this is 4 subtract 11, which is negative 7. Okay, and let's graph. The vertex is negative 2, negative 11. So that goes off of our graph a little bit, actually. So I'm just going to guess where that is. And then I have negative 1, negative 10. Ooh, I'm doing this on the wrong side. I'm sorry. Let me fix that. Okay, negative 2, negative 11 is actually over here. Negative 1, negative 10. Negative 3, negative 10. 0, negative 7. And negative 4, negative 7. Again, I know that mine is not great because it's difficult to do this on an iPad. But, okay, it's opening up. That's good. We have a positive 1x squared. So that's a good sign. Okay, so now you have one to do. This one you're just going to write in vertex form. I'm not going to have you graph it. I'm going to start it out with you. So this is like example 2 when we have this 4x squared. So I'm going to rewrite this. So I have 4x squared, subtract 24x, and I'm going to leave that negative 40 alone. I need to add some number so that I can complete the square. Well, that 4x squared is a problem. I need to start by factoring out the 4. So I have y equals 4, x squared, subtract 24, factor out of 4 is going to be 6x, and then I still have room to complete the square, minus 40. Remember that the 4 is not factored out of the 40. Okay, you see if you can go from here. Flip back to example 2 and do the best that you can. Good luck. Okay, let's see how we did. This number should be b divided by 2, negative 6 divided by 2 squared. Negative 6 divided by 2 is negative 3. Negative 3 squared is 9. Okay, I'm adding 9, but really it's 9 multiplied by 4. So I added 36. To counteract that, I need to subtract 36. Okay, now my perfect square trinomial should factor. Two numbers that multiply to 9 and add to be negative 6, well, that's negative 3 and negative 3, which is good. They should be the same. So this is really x subtract 3 squared. I then have negative 40 subtract 36, which is negative 76. In this case, our vertex is 3, comma, negative 76, so you can see why I didn't have you graph it. So hopefully that one went well. If you made a mistake, not a big deal. I'm going to give you one last example. This is one that you're going to do on your own and bring in tomorrow. Please factor y equals 3x squared, add add 6x, add 11. So I would like you to factor this one, or convert it, I'm sorry, from standard form to vertex form. When you come to class tomorrow, we will be checking to see how you did. Good luck.